Yes, my name is Derek Reich. I work for a company called Laser Technology. We design, manufacture, and distribute laser rangefinders across the world. About over 20 years ago, we designed a laser rangefinder that was used in NASA. They actually used this rangefinder for proximity and velocity with the space shuttle. We also have done recreational rangefinders, working with Bushnell back in the 1990s. We designed the first recreational rangefinder used for golf and hunting. We're actually still contracted by Bushnell today and still distributing and manufacturing these laser rangefinders. One thing we strive in our patents and our design. We innovated designs. We've got over 63 patents worldwide, all on laser rangefinders and different sensors, compass sensors, inclination sensors, and we combine all these to measure distances, inclination, azimuth to work in the GIS world. Over 20 years ago, we were contracted by the Forest Service, the U.S. Forest Service, to make a handheld total station. It was a Criterion laser rangefinder here, and we designed it, which really sparked our professional measurement division. This laser rangefinder measures distance, inclination, and bearing, and when you hooked it up with a GPS device, now you could get your current location GPS, and then you can also get a remote GPS location by using the laser rangefinder. From there, this is the latest technology that laser technology has. It's a fully integrated range and tilt 3D compass laser rangefinder. It's pretty much the only one that you can use, or the only laser rangefinder with the no pitch and roll limitations. This is our latest product line called the TruePulse product line. And today I have Alan from IFR to discuss the applications of using our technology in the field.
Thanks a lot, Derek, for the introduction. So, as Derek said, I'm Alan Zambarda. I work for IFR Monitoring and Mapping Solutions in the Czech Republic, and we are developing a software and hardware solution, especially for foresters. Today, I am going to introduce you the testing of the field map technology for the measurement of forest and agricultural parcels. Why do we measure agricultural parcels? We do that because thanks to the Common Agricultural Policy, European farmers are enabled to ask for European funds, which are many times related to the area of their farms. The paying agencies, the European paying agencies, are responsible for the whole process of funding, and the integrated administration and control system is what they are using to do that. Moreover, the paying agencies are responsible for the on-spot controls. Practically, they go in the field and they measure the area by GNSS equipment, so GPS equipment. This equipment has to be validated by the European body Joint Research Center. And what we have done here is to test our technology, give this testing to the GRC, the responsible body, and get an approval to use our technology for the measurement of the area in agricultural and especially in forest parcels. I will explain you why. So this is the validation scheme. You can see that first of all we had to design, so find a place in the forest where we establish our polygons, mark the borders of polygons, get the reference area with another technology, and schedule our measurements. After we have collected data, we had to process the data statistically and send it to the Joint Research Center for the validation. Why also in the forest? I told you that farmers are asking for funding, but many times farmers, they have a patch of forest, or forest owners, they are also unable to ask for European subsidies in different cases, like for Natura 2000 payments and others. In forest, you have to know that receiving a GPS signal is very hard. Sometimes it's even impossible. So we are proposing to the paying agencies our technologies that is laser-based and it's not influenced by the reception of the GPS signal. This technology, as I told you in the beginning, is the field map throughput technology. It is composed by hardware and software components. The hardware components are the Throughpulse 360B laser rangefinder, which allows the user to use distances, inclinations, and also azimuth. So it's good for forest, for full mapping in the forest and on the agricultural parcels. The data are sent to the field computers, and this the whole technology is mounted on a monopod, the way that the measurements are made from one precise point, so to increase the precision of the measurements. All these data are sent then to our software that is running in the field computer, and it's processing this data. Practically, it is calculating the area. So as I said, first we had to design and establish these polygons. We established 6 polygons, 1 square, 1 rectangular, 1 rectangular long, of a long shape, and another 3 of complex shape. All of them of a different area. In this slide, you can see the polygons, how they look like. The white area is the only part which is not covered by the forest canopy. And on the right side of the slide, you can see the condition of the forest, so it's completely covered by trees, by the canopy. The reference measurement we have taken by total station, because otherwise if we would take it with a GNSS equipment, we would have the problem of the reception in forest, and the total station, it is not influenced by that. So that was our reference measurement. And then we started to measure with our field map and Throughpulse technology on 9 series of on each polygon, 4 repetitions. 3 teams were involved on this, each of them with the same equipment but different units. So we could test also that the same equipment is working. This was not influenced by the revisiting time because we were not using GPS equipment, which it is you have to care about the satellite constellation when you go to measure with GPS in the field, because not always you have a full reception, so you have to revisit the same place after a while to get the best signal. But this is not a problem with the laser rangefinder. You can keep on working. So altogether, as you can see here, we have performed 260 measurements in total. After the measurement, we went through the data analysis, statistical data analysis, to get the buffer. The white of the buffer is practically the parameter which is stating the accuracy of our technology. With the field map software, it is possible also to use some special functionalities like this Bodwich transformation. In simple words, practically when you are measuring the polygons, you start from one point and you go all around, and you will never finish exactly to the same point because every measurement has a small mistake. By this Bodwich transformation, we can close exactly the polygon on the same point where we have started, keeping the same area, which is the data that we want to measure in the end. Also in field map software, it is possible to have a full topology. It means that we can close the polygons and get the area very easily by some wizard in the software. This is the validation result that we gained from the Joint Research Center. You can see that the buffer white is only of 0.34 34 meters, 34 centimeters, which puts our filmed technology among the best category of equipment for area measurement, together with the best GPS that they can get the same result, but not under canopy. So actually it can be used on agricultural parcels, on open areas, but the same way, with the same result, also under canopy and forest. Thank you very much for your attention. If you want to know more about this project and others, you can meet us at the LTI booth. Is in this hall is the E18. Thanks again.